Good morning, everyone. We'll go ahead and get started today. Carly's not with us today, so it's good to hear my voice today. Let's see here. There are on the side of your control panel, if you need to ask any questions, please put them in the questions section. I'll try to get to them as we go along, but if not, I'll get to it towards the end. Again, this recording is, or this webinar is recorded, so feel free to direct any of your dealers or anyone that might want to take a look at it to our YouTube channel, or you can go to our secure site and click on Intertech University. Once you click on there, the online video library tab will come up, and you can click on there and it'll take you straight to the YouTube channel. Then once you get there, you can subscribe, and any new videos, it'll let you know we've got a new video out there. So we'll go ahead and get started. Again, there's me, little bald-headed guy. Probably getting tired of seeing that little picture, but if you need to get a hold of me, there's my email address, as well as my phone number. Feel free to give me a shout or shoot me an email. Email is usually the best way, as I am working remote. So sometimes it doesn't always forward it to my phone. So email is the best way. So make sure that we've already checked before we ever put any kind of refrigerant gauges or anything on the system, that we make sure we've got water flow by checking pressure difference as well as temperature difference. Make sure you've got airflow if it's a packaged unit. So make sure that if it's a zone system, all the zone dampers are open, your blower's turning the right direction, things like that. Just make sure you got airflow, your filter is in place and it's clean. You've already done your heat of extraction, heat rejection formula, and that has obviously not come out properly. And again, we don't want to put refrigerant gauges on the system if we don't have to, just because that's a sealed system, and every time you put your refrigerant hoses on there, it's going to pull some refrigerant out. So we prefer not to put refrigerant gauges on there until we know we have to. So make sure we're always checking water flow, airflow, and heat of extraction, heat of rejection. So basically, the reversing valve in the system basically decides whether the unit is in heating or cooling mode. So you can see the kind of the picture, the path. The valve, without it energized, will be in heating mode. So you've got your discharge, you come out of the discharge, you go to your air coil, then you've got your suction, or you're coming back from your coax into your suction of your compressor. So in cooling mode, then we energize the pilot valve and shift the valve over, and then your discharge goes to your coax and your air coil goes back to the suction. There is a three-way pilot valve. This is kind of a cutaway of the valve itself. If ever you have an issue and you don't think that it's shifting, the temperature of the lines are what you'd probably want to look at. A lot of times what I see when a valve is stuck maybe halfway or something, mid-position, a lot of times I don't necessarily see the refrigerant pressures equalized, but they'll be pretty close. Maybe like a 140 and 160, or 140 and 180, something like that. But normally they're not exactly equal. When they're exactly equal, that's normally something in the compressor and it's not pumping. So if you see them exactly equal, that's probably a compressor issue. If you see them off a little bit, it's probably the bleed by. And like in this example, if you wanted to check temperature difference, you would check that discharge pipe and also where it says air coil, hydronic coil. Those two lines should be 3 to 5 degrees of each other, probably closer to the 3 degree. And then your suction and your loop field connection there would be, the same temperature as well. So the pilot actually switches a little solenoid in there, and then the refrigerant pressure actually pushes the valve over, slides it over. So it's discharge pressure is what slides it. So if you don't have, if your compressor's not pumping and you want to shift that valve, it's not going to shift because you have equalized pressures on each side. So there's no force difference to be able to slide that valve over. The actual electric portion of it up here in the top doesn't actually change the whole valve over. It opens up this little pilot, allows the suction or the refrigerant in the suction or from the discharge to bleed over into the suction, causing a less pressure on that side. And then you've got discharge on the other, and that's what slides the valve over. So it's actually not just electrical that's making this valve slide. It's actually refrigerant that's making it slide over. You can see there's the discharge pressure that's running through that solenoid valve and then pushing on the end bell of that reversing valve and sliding it over. In heating mode, the valve is not energized. That's our fail mode. So if there's no power to it or the solenoid fails, then the valve will be stuck in heating mode. I think pretty much all manufacturers power our valves in the cooling mode so that they always fail to heat. I'm not necessarily exactly sure why they do that, but I guess they figure people would rather have heat than have cooling. But if you've spent any time in the field or dealt with homeowners when their unit's not working, it seems like they get a little bit more upset when they're hot than when they're cold. So, but that just seems to be the industry standard is fail to heating mode. So that's where we do as well. So we power the O in cooling mode. There you can kind of see that little pilot actuated valve, how it just kind of dumps that refrigerant back through the suction to switch it over and push on that end bell. That's why you've got all those little bitty 1/8" pilot tubes on the valve itself. You'll see them on both end bells near the solenoid pilot assembly, and you may have seen a few of those back in the day, especially on the water-to-water units. Right at where the solenoid was, one of those little 1/8" lines would snap off, and it'd be a clean break. If you ever do see that, that's normally caused by some kind of vibration or harmonic imbalance in the compressor. That could be due to not enough load or source water flow, or running high pressures for some reason, whether that be a high aquastat setting or something. But that's when we see a lot of these little pilot tubes break. We don't really have a whole lot of issues with the reversing valve itself until we get into not enough water flow and we get a lot of vibration. But for the most part, they're pretty reliable. We don't have a defrost circuit or a defrost every hour or so like a air source heat pump. So when our valve shifts into cooling mode, the valve will be energized until the thermostat is taken out of cooling mode. So even when there's no call from the thermostat, as long as it's in cool mode, there's always an O signal to this valve. So it's always shifted over to the cooling. It never shifts until you take the thermostat back out and put it into off, or you put it into heating mode. So we're not having that valve shift all the time, which definitely saves us on the valve. There's basically the path of the refrigerant flow in heating mode. Obviously in cooling mode, it's going to slide over. O is energized. There's the path of the pilot coming back through, bleeding over to the suction, pushing on that discharge pressure and sliding that valve over. So now there's the path of the refrigerant. If again, we kind of discussed that. If you have power to a solenoid but it doesn't shift, then there could be something wrong with the coil itself. You can ohm out the coil. If it's open, then replace it. And you can just take the little screw off the shaft on the reversing valve and just replace the coil. We may send you the whole thing, but if it's just a coil, I don't expect you to break into this system and, you know, cut it open. We would recommend that you let us know that it's just the coil, so we don't pay you, you know, $400 or $500 for the repair when it takes you 2 minutes and, you know, a $30 part. So just let us know. And again, we may send you the whole valve. I'm not really positive on that, but you can just replace the solenoid itself. You can do that on a TXV too. If you think it's just the head or the bulb, you can just replace the head without losing refrigerant. Just a side note there. Checking for electrical operation, basically the reversing valve goes right back to the lockout board. The bottom terminal is your O terminal, and the second one down there on the left is your common. So give it a cooling call and check to make sure you have 24 volts between common and O on the lockout board. If you don't have it at the lockout board, it's going to go from the lockout board to the ECM board if you got a blower on it, and then from the ECM board to your thermostat. So check back to the ECM board. If you don't have it there, check at your thermostat connections. If you don't have it there, you may just want to pop off the terminal strip, and you can jump her out R to O, and then trace your power back and see if you're getting it from the lockout to the lockout board then. There's not really a whole lot that'll hold it after you get past the thermostat. So it's basically just jumpered off of the ECM board and then goes over to for the call. So again, there's not a whole lot in between there. I would suspect maybe a thermostat issue if you don't have power to the lockout board. Again, 24 volts, minimum 18 volts before it's really going to close that. So make sure you've got proper voltage. If your voltage seems off, check your transformer taps. We do wire it at the factory for 240. So make sure you've got your 240 volt. Refrigerant leaks. The valve body, I don't see that a whole lot. I did have one, let's see, what was that at? Actually, I think it was at our human resources lady at Intertech, Jill. I had to go out to her house a couple of years ago. She's got an older, one of those white cabinet GeoComfort units, and water furnace built, I believe. But I went out there to find a refrigerant leak on hers, and I could pick it up with a leak detector in a cabinet, but I could never. It was really hard to find. I ended up getting soap bubbles out, and it was actually leaking. The end bells on this reversing valve are kind of sandwiched in there, and then they're soldered around the end. And it was actually leaking on the end of the actual valve where that solder was. And it was a real small leak, so it's really hard to find. But it was actually leaking right there on the end. But the body of the valve, I have seen a few times where the copper meets the brass on one of these nipples, one of these 4 nipples. Not real often, but every occasion we'll see it there. The body itself, I don't see that really leaking unless it got hit by something pretty hard. The pilot tubes are usually the culprit, and that's normally due to vibration. So check the pilot tubes real close. I know back in 2012, we had an issue where the bracket that holds the solenoid on the valve, there was only one screw on there, and if it did have a little bit of vibration, it would rattle around and snap one of those tubes. We did switch manufacturers, or actually I think maybe the bracket got switched. I'm not quite positive on that, but I know it got addressed, and there's now 2 screws on that bracket, and we haven't had that issue that issue kind of went along with high water temperatures. So we've also kind of handled that issue too, and talking about on a water to water unit about aquastat settings and setting them too high and causing compressors to pull high amps and rattle around and stuff. So we've gotten that pretty much taken care of. Again, for the most part, the reversing valves are pretty reliable. I know that they're not a whole lot of fun to replace. I've done it numerous times, and so I don't want to just throw a reversing valve in a system unless we really know that that's the problem, because again, like I said, they're not a whole lot of fun to replace. If it's ever sticking and heating or cooling, you can tap the valve and see if it'll shift. I wouldn't like hit it real hard with a hammer, but because you could damage the valve. But at the same time, it's already sticking. It's not really going to hurt it too much to tap it. Another thing, if you really want to know if it's sliding or not, on the end bell of the slide, in this picture here, it's kind of offset to the center there, but on the ends of that slide, there's metal in there, and you can actually take these little earth magnets, and they will not stick to the body of the valve because it's brass, but it will stick to the slides on this reversing valve. So you can put one on each end of the slide, and you can energize and de-energize that valve and see if it slides those magnets back and forth. Now, it won't let you know if it's necessarily traveling all the way, but it'll let you know if it's shifting at all. Another thing you can do is if the valve won't shift, maybe it's got some kind of debris or something in the pilot tubes. If you've got a great big magnet, sometimes you can put it on that valve body, energize the valve with the, give it a call, and sometimes you can grab that slide and slide it over if your magnet's big enough. It's got to be a pretty big magnet, and again, you may get it to slide over, and then at least maybe get him, cooling, but it may or may not work. I'm not going to guarantee that it's going to work, but you can definitely try it, if you're in a pinch. Debris is probably the biggest culprit of a valve not wanting to slide. Debris, and if you replace a valve, overheating that valve. It's real easy, obviously, to overheat these valves because you've got, those three bigger lines right all together. And you put a little too much heat, and there's Teflon seals in that slide, and they will melt. Once they melt, they're going to warp, and then it's probably not going to shift. So be real careful when you're replacing a valve that you don't overheat it. If the coil ohms out and it's good and it still won't slide, replace the valve. Mid position, again, you're going to see pressures not equal, but somewhat close. You'll probably have a really loud compressor as well, and it may actually go out on internal overload. But when it sticks mid position, that's usually caused by heat or something wrong with the slide itself. Debris will normally make it so it doesn't slide at all because the debris gets stuck in those little 1/8-inch pilot tubes. And then you don't get a differential pressure switch and it won't slide over. Temperature difference is the best way to know for sure if it's sticking mid position. If all 4 lines are the same temperature, then more than likely it's stuck somewhere mid position. Now, before you definitely say that that's the case, make sure you look at your refrigerant pressures and make sure they're not equalized. If they're equalized, of course, all the temperatures of the refrigerant lines are going to be the same. If they're all equalized, I'd take a closer look at the compressor, maybe pull an amp draw on the compressor, and then maybe engage and disengage that reversing valve and see if any pressure changes at all. But if they're equalized pressures, I would look harder at the actual compressor itself. It will sound like a scroll compressor running backwards, which is pretty easy to tell. And again, the compressor will run hot. When the inside seals leak and it does shift, that's when you're going to see a pretty easy temperature difference across it. So some of that discharge hot gas is going to bleed over into your suction or your colder vapor there, and you're going to notice a pretty big change in the suction lines there between coming in and going back out. It says 6 degrees. It's probably, it's going to be a lot greater than that, more than likely. 10, 15, 20 degrees difference in the two. So it's pretty easy to tell. Sometimes you can even feel it with your hand. So temperature difference is a good way to know if it's bleeding through. Never hit a reversing valve. It will dent. It's brass. So you could cause more problems than what you already got going on. So if you're going to hit it, just be careful. And I would probably use maybe a rubber mallet or something like that. Well, they say when in doubt, just get out a bigger hammer. Probably not the best idea. Make sure when any technician or anything, you're cutting into the copper, never use a saw. Those are fine metal particles, and that's the kind of stuff that's going to get caught up in the pilot tubes of the reversing valve itself. So always use tubing cutters. Always cut out fittings or valves and fittings in the system. Don't unbraze anything because you're looking for problems in small pilot tubes and equalizer tubes when you do that. Make sure we're obviously changing the filter dryer when we break into the system. We always will send you a filter dryer if it's under warranty. You don't have to request it. If you're ordering anything in the refrigerant circuit that we know it's got to be open, we always send you the bi-flow filter dryer. I always hate it when I request parts back and I get back an unused filter dryer. Maybe you use the one you had on your truck because you like it better or whatever, but it makes me think that maybe you didn't change it. So I always make a note in the computer. It doesn't necessarily mean you didn't change it, but it's just a bad look when I get that filter dryer back. Make sure you're always replacing that anytime that you're in the refrigerant circuit. If you have to replace a reversing valve, I would cut it away from the valve and then take the valve outside. And if you want to reuse these stubs, then mark them. And then you can run some nitrogen through there and unbraze them outside. Another thing that you can request if the unit is under warranty and you're filing a warranty. Now, I don't know if we have it for all the units, but there's quite a few that we do have it for. You can put in a note section on the warranty that you would like the spider assembly. The spider assembly is basically going to be what you're looking at right now on the screen. We're going to send you copper coming. We're going to braze it at the factory at the 4 nipples on the valve, and we're going to give you the copper pieces. And then you can cut wherever you want once you get it in the field. Obviously, the farther away from that valve, the better, because that's why we got the spider assembly, so you don't have to worry about overheating it. We did it, try to make it easier for you guys in the field. I know how hard these reversing valves are to change in the field because I've done it. I've done all the work on these units. There's nothing that I haven't done or wouldn't do again. I know from experience how easy it is to overheat that valve. So ask for a spider assembly. If we have it, we will definitely get it for you and braze it up at the factory ourselves. And then you can get some slip couplings and braze it in anywhere in the line you want. So it'll make it a lot easier for you guys. So just keep that in the back of your mind to make sure to put that in the notes section if you're going to replace these. Basically, if you don't have the spider assembly, just cut it out, mark your lines, and then you can unbraze it. Whenever you're refitting, make sure you dry fit it using your marks. Use some paste or wet rags or something and wrap the reversing valve itself, the body of it, so the Teflon seals don't melt and warp and bleed. Now, I have had guys, you know, they call in and say, I just replaced the reversing valve and this is what it's doing. And, you know, you tell them, well, unfortunately, that valve is stuck and it probably overheated. You can usually tell how the valve looks if it got overheated or not. You'll see rainbow and everything else on it. And, you know, no offense, but it's normally a newer technician who just hasn't had a whole lot of experience brazing. You know, I'm not gonna lie, I've overheated valves before, but you know, it's sometimes, unfortunately, that's how you learn. But it's real easy to overheat them. So make sure we're using the paste or a wet rag. They have a spray gel too. I'm not a big fan of the spray gel, just because if you get one drop on a place that you don't know and you're trying to braze on that spot, it won't take. So I'm not a big fan of gel. The paste seems to work pretty well for me, and I've always got wet rags, so that's what I use quite a bit of, is the wet rags. But whatever you feel comfortable with, you know, I'm fine with that. Just try to keep water from getting into the refrigerant circuit, because that can be a huge contaminant, and that'll take a while for your vacuum pump to pull out. So just be careful when you're using the water. You can use slip couplings. So you can put the pipe together and slide that coupling over. If you don't have a slip coupling, you don't have a coupling with a little nipple inside, a stop nipple, you could actually take a little file and file down that nipple and make a slip coupling out of it. I've done it a few times when I've been in a pinch. Compressor burnout is a big problem with reversing valves sticking, because of all that acid burnout stuff gets caught up in the pilot tubes. So if you have a compressor burnout and you want to replace the TXV and you want to replace the reversing valve, Intertech's position is we have no problem. I will approve that every time. I would rather have you replace those parts than get the compressor in, turn the unit on, and then the reversing valve's bad too. You know, as a technician, you know, you spent 4, 5, 6 hours, however long it takes to do the job, and you start up the unit and it's not working properly. You've got to go all the way back through that. You know, so it's kind of disheartening a little bit. You know, you're like, oh yeah, I finally got it done. Looks good. Got all the insulation, everything back on. Bam, you're right back into the refrigerant circuit. So as a precaution, you can put in the notes section on your warranty that you want an expansion valve and a reversing valve, and we will send out those parts. Obviously, we're only going to pay you labor for one. That's why we really don't mind it as much. It definitely saves us money, and it saves you guys time and money as well. So definitely request those if you want to replace those, if you think it's a compressor burnout. An easy way to tell if you've got a compressor burnout, a lot of times, is smell, but you can also do an acid test. And I know Checkmate offers a acid test kit, and I believe we actually sell it now. That'll check for acid and moisture and contaminants in a system. So if you do have acid in the compressor, then definitely get the reversing valve, and there are acid cleanup procedures that need to be done on that. If you need some assistance with that, give tech support a call, or you can also check out our website and our tech bulletins or tech tips and notices that has a process for cleaning up a compressor burnout, which I believe it does talk about possibly replacing that reversing valve as well. So don't be afraid to ask for those parts on a compressor burnout. So with that, I mean, there's not really a whole lot with the reversing valve. Again, they're pretty reliable, especially for us, as we're not shifting back and forth a whole lot. So we don't have a whole lot of warranty claims. And we always try to make sure we double check when we diagnose them, because we don't want to have to replace that if it's something else. It's just a bear to replace those valves. I don't know if you guys have seen where they sit, but there's a lot of stuff in the bottom of that compressor, and it sits about in the middle of that cabinet. So it makes it a little bit difficult to change out. I know, I've been there, I've done it. So I feel your pain when you're in the field doing it. And that's why we always want to make sure that we confirm that it's the reversing valve and nothing else. So with that, if you've got any questions, feel free to ask. But I won't keep you long today. We do have next week, I'm doing a little service procedures, which will cover, scaling calculations on an open loop, changing out pumps, things like that on the geo units. And then on Thursday of next week, I'm going to talk about the SK fluid cooler for a little bit. So neither of those will be super long, under an hour. So I just did post those on the website today. So you should be able to go ahead and register for those if you'd like to attend those. So thanks for sitting in today. I appreciate it. And have a wonderful rest of the week.